So in this video, we're going to graph equations that have the form x equal a, and these are going to turn out to be vertical lines, which will mean that they will not pass the vertical line test, which is why we're using the word equation here instead of function. So graph the equations x equal to -4 and x equal to the square root of 15, then determine their domain and range. So we'll start off by drawing in our x and y axes. So here's my x-axis, here's my y-axis, and let's label those x and y, and let's think about x equal to -4 first. So if this says that x is always -4, this means that x will never be 0. The only way x could be 0 would be for you to have a line that intersected the y-axis, because when you intersect the y-axis, the x-coordinate is 0. So 0 comma whatever the y component is. So this tells us that if x cannot be 0, then our equation x equal to -4, because it can't be 0, must be parallel to the y-axis, because if it's not parallel to the y-axis, then it would intersect the y-axis at some point, which would give us an x value of 0. So I'm going to come over here. Because x is negative, we're going to go to the left of the y-axis. I'm going to pick a place that I think is a nice place to draw in my function. Let's go ahead and make it a different color. I think would make some sense. So we're going to go pointer options. Let's go ink color over to black. So I'm going to draw my function in right here, or not my function, my equation. So here's my equation, x equal to -4. And then I'm going to label the value on the axis here in a minute. But first I want to go ahead and take care of the other equation while I'm at it. So this is the equation x equals -4. So we also have an equation x equal to the square root of 15. And this says x is always the square root of 15. So the first thing we know is that it will never be 0, which again will mean that we can't have a line that crosses the x-axis, or sorry, the y-axis. And if we can't cross the y-axis, then we will need to be parallel to the y-axis. And then what I want to think about is what does the square root of 15 look like as an approximation? Well, if we had the square root of 16, we know that would be equal to 4. So the square root of 15, which is just a little bit smaller than the square root of 16, has to be a number that's close to 4. In fact, if we look at the square root of 15, and we say, hey, what is he equal to? Well, the next perfect square down would be if we took the square root of 9, which would be 3. So I know the square root of 15 has to be between the square root of 9 and the square root of 16, which means it has to be between 3 and 4. But 15 is so close to 16 that the square root of 15 will almost be positive 4 units. So if I've just graphed x equal to -4, I know that my equation x equal to the square root of 15 will be, if this distance here is 4 and the square root of 15 is almost 4, my function should be almost exactly the same distance from the y-axis as my equation x equals square root of 15 should be almost the same distance from the y-axis as the equation x equal to -4. So I'm going to come over, eyeball it so I'm about the same distance, maybe a hair shorter. I'm going to draw in my vertical line that I'm going to try to make look parallel to the y-axis as much as I can. And then this is going to be x equals the square root of 15. And then I can go in and put some labels on the axes if I need to. So switching back over to the red color. So go down to pointer options, ink color, back over to red. I know right here, I know that value is -4. And actually right here, I know that tick mark represents the square root of 15. And then I want to take just a moment to make sure, do I have my x and y axes labeled? Yes, I do. Do I have arrows on each of the axes and each of the functions? I do. Did I put labels in that were appropriate on the x-axis? I did. I don't really need scaling on the y-axis in this case because I don't have to plot any coordinates with respect to the y-axis. If I wanted to, I could give it one-to-one scaling with the x. I could say, hey, that's like 4 units, so that's like 4 units. I could do that, but I don't think that it's particularly necessary in this case. So I think this graph accurately represents the two equations that we have, and then we just need to determine their domain and range. So let's start with x equal to -4. So the domain for this guy is really simple. What can x be? Right? The domain is what can the inputs be, and we see the inputs are just -4 always. So we can't use an interval, we'll have to use a set. So x is an element of the set that contains the singleton, a -4. And the range of the equation, or the relation, is going to be, those are our y values. Well, where does y go with this guy? Well, he's going to positive infinity, and he's going to negative infinity based on those arrows. So we see that y is an element of the interval, the open interval from negative infinity to positive infinity. And so we'll get something similar for x equal to the square root of 15. The domain for the square root of x equal to square root of 15, the domain is going to be x can only be the single number, the square root of 15, and that's all he can be. So set notation is appropriate, interval notation is not. The range is going to be the same as the range for x equal -4. These two equations are going to the same place. So we'll say the range is an element of the interval from negative infinity to infinity.